Hello, this is Greg Brown with Cognex Duluth. I am giving a presentation on inputs and outputs using the EasyBuilder interface. We'll go ahead and get started with the session this afternoon. Of course, if you come online later, the telephone number here was listed in the email that you received just this past week. Let's go ahead and get started then with the EasyBuilder user interface on the Section 8, Inputs and Outputs. What we'll be covering is the differences between the different input-output expansion modules, some of the difference between online mode and offline mode, what that means to you and the significance to the camera. And we'll be doing some configuration, the discrete input line and the discrete output line. The screen, as you see here in the online session, is the Insight Explorer EasyBuilder View 4.1. What we're pointing to right here is the inputs and output section. It's step 3 in configuring your camera. And so I would like to point this out to you when we get to the EasyBuilder interface. And we can go ahead to the next slide here and see this, the two inputs. This is the discrete input slide and the discrete output section in the EasyBuilder view. These allow you to send from the Insight Explorer from the camera to send and receive signals to other external devices. And also in our EasyBuilder view, we have an I/O tab here for showing the state of those inputs and outputs. One of the things you would do when you set up the EasyBuilder would be to configure it for which I/O expansion module you have on there. And so we can show you this right here. This will be able to be demonstrated again when we open up the EasyBuilder Explorer and show you that slide or that device. The Insight, or not the Insight, the Cognex I/O expansion module, the one we're using here is the 1450 expansion module, which I'm using here in my office to demonstrate to you. These are the different inputs and outputs. As you can see right here with the 1450, we have our 8 inputs and our 8 outputs. We also have 2 high-speed outputs. And that will be the module we'll be using, and the indication of the inputs and the outputs will be right here in my office, and I'll tell you which one of these LEDs we'll highlight when we get to that stage of the demonstration. Another module that we have is the I/O expansion module, the I/O Ethernet module, which is currently our WAGO 750-341. Required if you need to go over the Ethernet and get more than 8 input and 8 outputs. You can, of course, expand it with the Ethernet I/O. Some of the considerations that you can do with this is you can start adding more input and output modules to this. And so right here we have 4 inputs and 4 outputs added to this. And to attach this, you select the I/O module, but you'll need to be able to configure it using the IP address of the I/O module, the WAGO unit. And the update time, as we're pointing out right here, is how long it takes for the Ethernet to go across the Ethernet. Discrete I/O is very, very fast. It's a hardwire item from the camera straight out to your external device, where the Ethernet is triggering over the Ethernet to this module right here. So realize there is some amount of time delay over your Ethernet line. Configuring the results and the inputs. So you go into this input module right here, and it will open us to this screen right here. Discrete inputs. We can set up line 0 as a trigger, meaning that's an input. We'd have to send 24 volts to the line 0 for a trigger in there. We'll define that over here as a acquisition trigger. This is set up here to set it up for an external device to trigger your camera, such as a photo eye or a PLC, whatever you happen to have it triggering. Another input signal we can describe as either being an online acquisition trigger. Once you use this right here, you're going to be forcing the camera online if you so chose online offline with say line 1. Then as you received a signal from line 1, 24 volts on that line, it would then force the camera into an online or offline mode depending on whichever state it was before. It's a toggle function. That's another functionality for our input signals. Once we have that, such as an acquisition trigger, we can choose rising edge or falling edge or both edges, depending upon what type of signal timing we are looking at and how long your pulse is with your input triggers. We do have that capability with that. Other functionality that we offer through the EasyBuilder user interface is to test these inputs by forcing them on, so that you can verify that the input is working correctly. Another area we have to work with here is the outputs, and we can configure them also the same way we had with the inputs. We have some various ways to do that. First, we have to verify that our module is connected to the correct breakout board for us. The expansion, we're using the 1450 expansion board in my room. Once there, then we can go in here and define what line 0 will be. This is going to be a job fail, so that'll be an overall result that we would have for this one. And the signal type here, we can tell it to either when we have a job low or when a line goes high. We can force this line to stay high, stay low, or when such a thing as when it goes online or offline. Well, basically when it goes online, this output signal then would go high. So we can configure it, hardwire it this way. Some different selections in here again. Several missed acquisitions. Again, these are all lines to signal output signals when these states come about. And working our way down the column here. I'm not going to go too much into those anymore. What I want to get to is this is basically where most of us will be working at right here, is on our job results. We'll be defining whether we want this total job fail right here over all the sensors. If any one of the sensors fails, then our job fails. Or perhaps we might want to pick a particular feature of the product. If that particular feature fails, that we want to know about that, and I'll put that signal on one of these other independent lines through here. And that's where we would configure that, is in that's the signal type, but over here in the job results, these will be the breakdown of all your tools. With each one of these lines, you can select those, and we'll be able to demonstrate that for you in class. And again, like our inputs, we can also show you or force this on to see if it is working. So those kind of functionalities there, very useful. When we have our output, we do have to determine whether we need to pulse that output. And if we do check this box, then we'll determine this is going to have a pulse for at least 10 milliseconds. in case you have a PLC that needs either shorter or longer pulse, you can certainly configure it through the user interface. Another functionality here that we have to offer is our acquisition delay. So as you can use the acquisition delay here as if your cameras are in a product or in a machine. Product is in there, and of course your reject station is 2 or 3 stations down. What you can do is say, I won't output that failed job result fail until 3 acquisitions later. And so that is our acquisition delay functionality for it. Our online function in our setup step, step 1 there. We can configure the camera. When this goes online, we can tell the camera to either go in continuous mode or look for a camera trigger, look for an external trigger such as a photo eye, a manual trigger, and we can also configure it for a network trigger, which we go into a little bit later in our communications section. Another functionality with the online function is we can go through our Save Job step here, step 4, and start the sensor in an online mode when the camera starts up once again, and select a job to start up with. Another feature that is available to us. When we're online, we have the online indicator in the toolbar, and in the image window down here in the lower right-hand corner of your user interface, it'll be offline or online. And in the lower left-hand pane, we will also have an online indicator, which is not highlighted, and the online indicator is highlighted when we select online. With some indicators in the user interface to help us understand if the camera is online or not. Online means that the camera will update all your input and output signals and communicate outside the camera. Offline means the input and output signals are disabled, but also this is when you are programming it and determining what we are going to use for designing the user interface. When you are online, you are not able to design or interface with the EasyBuilder user interface to configure it. So there's little differences there for being online and offline. And like I say, when we have our forced input and output functions, we can also see it in that lower left-hand pane down here. It'll be a forced I/O. And we also have in our I/O tab the indicators with the LEDs. Will turn either gray when they're not used and green when they're high. And those are all the 2 states that you will see them in. We don't have red or green. We have just the gray state not used or green indicating they have gone high. So let's go ahead and jump ahead here and get into the actual user interface here. So what we're going to do here is share that user interface with you. And so you should be able to all view this user interface here on the screen, on your screens there over the internet. And I've already configured it here with the Cognix logo. This is part of our other sections that we had. We had used the positioning tool to fixture our tool. And I'm just using a blob count tool down here to indicate LEDs, whether we have 3 LEDs present or not. So I'm using that as my indicators. And all this process had been learned in the other section. What we're going to be doing here is looking at the inputs and outputs. On our inputs, this is our input section right here. So we have lines 0 through 7. I can define these inputs as going online or offline. So if I did this, I don't have something hooked up to my line 0 right now, but as I go online here, you'll notice it's looking for a discrete input into line 0 in order for it to go online. I don't have a hardwire to that right at the moment, but that can be remedied later. So that's our input functions. We can also, set up line 0 or line 1 here to look for an acquisition trigger, in other words, to trigger it from like a photo eye, functionality like that. And we can also do this online, offline, and functionality there. We can force our onlines high and look at our functionality over here in an I/O tab. Yes, I have forced it to go high. Turn it off, and it is grayed out. But what we're most interested in at this point probably is our outputs. We want to be able to configure our outputs for job fails. We can do a job definition over here and do it just when a job load okay. It will output a high or low, or when it goes online, it goes high. These are only output signals. Generally, as a rule, we'll be looking at these as a job result. So we'll take here, and I've got some blobs, pass or fail, a job fail, or I could even indicate an output line with just my locator tool if it fails. But I'm going to go ahead and take a look at this. Most likely we'll want to know when the blobs fail for the LED count up here. So I've indicated with line 0 that I wanted to go high when the blobs fail. So I'll make sure I'm in a manual trigger here for this one. And I will go ahead and keep outputs up here so that you can see what we're talking about here. So I'll go online, and we'll be looking for this to go high. Now we are in a pass state. We have green up here, so everything has passed. And I'm going to go ahead and flip the demo plate, which there are images of this on that. And here we have the LEDs fail, indicated with this red line around here. And if you'll notice here in our outputs, this LED has turned to green, meaning line 0 has gone high. And as I look at my breakout board here, line 0 LED has also turned on. And as I go through here and trigger it again and flip it, and update this acquisition trigger with that, we notice here how the line has gone low, grayed out, and on my breakout board, the LED has also turned off. So those are the functionalities, our input, output. Also, I'd like to point out to you, let me go offline here, so these become highlighted. If you'll notice here in the bottom part of here, we do have our high speed out and our green LED and red LED. These are our LEDs right here that are on our cameras, the 5000 series cameras, the 5400, what I'm using right here. And these green LEDs, you can of course have them do the same thing with a blob passes. Of course, you'd want a green LED, and on this one, as they fail, the red LED, I would probably have either an overall fail, job fail, or maybe just the LEDs or the maybe locator tool. But these are the indicator lights that are present on your cameras, on the back of the camera, to be able to find those functions. All right. Going to go ahead and back to our session here. And again, like I said, this is where we were looking at the section here with the LEDs and the I/O and the indicators there, so that you can simulate the breakout board for you so that you can be able to see that. Basically, that is our input-output section. So if, of course, you have any questions, I know there's no one on audio online, but we are certainly welcome to take some chat sections if you want to do that, to ask me any questions at this time. All right, I see that there are no questions. I thank you for attending today. That was basically our Section 8 input output. Again, you can find this lab on our website in the training section. with the, we do have the slide presentation there, and also the lab is there also if you want to download that and go through this on your own. Again, thank you for attending, and that's what we have today. Hope to see you again next week on Friday at 2 o'clock. Have a good day.